So we're looking at an example of finding unknown and mean deviations when we have both the unknown mean and unknown deviation. The process that we use is exactly the same as we did when we find one unknown mean, except for we're going to have two of them this time. So let's have a look at the calculations that we look in here. So we've got one calculation where our x value is greater than 35, it's equal to an area of 0.32, and we have an x value that's less than 8, which has an area of 0.26. First thing we have to do here is let's rewrite these in terms of z-scores. So we'd have 35 minus your mean over your deviation is equal to approximately 0.32, and then z-score is less than or equal to 8 minus your mean over your deviation is equal to 0.26. So what we need to do here is we need to find our z-scores for each of these. Now, let's look at how we do our z-scores again. So remember, your z-scores are using inverse norm. So inverse norm, let's do the left-hand side. So you have a right tail this time. So right, your area is 0.32. So 0.32. Your deviation, well, we're going to make that 1, and your mean is going to be 0. If we click this on here, we get something approximately 0.468. So we now can rewrite this here as 35 minus the mean over deviation is equal to 0.468. If we did the same thing on the other side, what we would have here is 8 minus mean over deviation is equal to, and I've already done this calculation, negative 0.643. And all we're doing here is just rearranging the formula so that way we can get into a form where we can simultaneously solve them. So if we rearrange this here, we get 35 minus the mean is equal to 0.468 deviation. 8 minus the mean is equal to negative 0.643 deviation. And what we could do here is we could equate both of these to find out what our unknown mean and deviation is going to be. Now we can do that simultaneously, or we could do it by using your calculator. Now if we're going to use your calculator, what we want to do here is we want to rearrange this so that we've got x and y on the same side. So if we rearrange this point here, we're going to call this here 1, and we'll call this here 2. We'll also write just up here, let the mean equal x and let the deviation equal y. Okay? So in this case, we're going to have negative deviation minus 0.468 deviation is equal to negative 35 minus mean plus 0.643 deviation is equal to negative 8. So now we can simultaneously solve both of these questions to find out what our x or what our mean and deviation is going to be. So if we go into our calculator, what we're going to look here is we're going to go to a function called equation. In equation, you're going to go to simultaneous solve, and we want two unknowns. So let's put all our information in here. We've got negative 1, negative 0.468, negative 35, negative 1, 0. Let's change that one there. So that one should be 0.643 and then negative 8. Once you've got that information in here, remembering mean is equal to x, deviation is y. So if we now click solve, we're going to get we're going to get our answers here. And our answers here will tell us that your mean is equal to 23.626 and your deviation is equal to 24.302. Okay, so when we're looking at these calculations, again, how do we know these are correct? Well, one way we can do is just check it with one of these functions here. Okay, so let's now check if our distribution, we have a mean of, let's do 23.6 and a deviation of 24.3. If we plug it into this function here, we should hopefully get 0.32. So menu to distributions, normal CDF. We're looking for greater than 35, so 35 is the highest, so let's go down, let's change that to 35. Enter, one with a lot of zeros. Our mean or our deviation was 24.3, so 24.3. Our mean was 23.6. 23.6. And let's press execute, see what we get. We get approximately 0.32. So we now know that's correct. We don't have to worry about doing the second one because we simultaneously solved this function to get those two answers. So what we've done in this example is we've used what we learned with finding unknown means and deviations with two functions or two probabilities that have no mean or deviation. We solved them by using that same process, but then we simultaneously solved the two questions to get our mean and deviation. Always remember to check. Do these numbers make my question, my initial probability correct? And if it doesn't, then we need to come back and see where we went wrong. I'll see you in the next one. Good luck.